In this video, we're going to look at how we can find the fixed points of a recurrence relation. So the first question is, what is a fixed point? Well, let's say x is a fixed point. Then what this means is when I substitute x in for un in my recurrence relation, my end result, un plus 1, should also come out equaling x. So in other words, the input is going to be equal to the output. So if we consider the fact that this recurrence relation here can be written in sort of function notation, we can say un plus 1 is equal to some function of un, because the right-hand side is just written in terms of un. Okay, then your fixed point x will be such that x will be equal to f of x. So if we substitute x in, our output should also be x. Therefore, at my fixed point, un will be equal to x, but also un plus 1 will be equal to x. Okay, so this is the key bit of information we are going to use to actually find our fixed points. So let's go to my recurrence relation and let's make use of this. What I'm going to do is replace the un plus 1 and the un with an x. So I would get x is equal to 5x subtract 6. And then we just have to solve to find x. So we'd subtract 5x from both sides, so we get negative 4x is equal to negative 6. And then divide by negative 4, so x would be coming out as positive 3 divided by 2. And that would be my fixed point of my recurrence relation. Now, will we ever reach our fixed point if we were to generate the terms of our recurrence relation? Well, that would depend on a number of factors. Okay, one factor it would depend on is what is the first term in our sequence. Another factor would be what is the gradient close by to my fixed point. And when I mean the gradient of my recurrence relation function here. If I was to calculate the gradient close to 3 over 2, what that value comes out with would actually influence whether we'd go towards 3 over 2 or not. And that is something you might look at in more detail during your numerical methods lessons for single mathematics when you look at something called fixed point iteration. But then the other question is, how is this different from finding limits? Because we used to do something very similar for that. Well, a fixed point, so our x equals 3 over 2, is a possible limit of my recurrence relation. Okay, remember, our sequence should approach our limit if it is a limit. Okay, and then that would depend on the first term in the recurrence relation as well as the recurrence relation formula we're given. So actually, the format of the one we're given here is very similar to the one that we've looked at finding the limits of previously. And we know when we have this format here, we look at the number multiplying un. If this number is between 1 and negative 1, then the limit will exist and therefore we'd approach our fixed point. Whereas if this number is outside of the range of 1 to negative 1, which is what we've got here with the 5, then it will not go towards a limit and therefore will not go towards our fixed point. Now let's look at finding fixed points for more complicated recurrence relations, which don't take this format which we're more familiar with. So it says find the fixed points of the following recurrence relation. So we got our two subscript terms un and un minus 1. The fact that it's n minus 1 does not matter. The same approach can be taken. What we need to start by doing is replacing all of our subscript terms with, say, x. So we would get x is equal to x squared subtract 6. And then we have ourselves a quadratic in x which we can solve. Okay, so let's make one side 0. So I'd get 0 is equal to x squared subtract x subtract 6 if we subtract the x to the other side. And then let's solve this. I believe we can factorize it, and it would be x take away 3 multiplied by x plus 2. So therefore our fixed points would be x equals 3 and x equals negative 2. Let's have a look at another one. So it says find the fixed points of the following recurrence relation, and you can see this time we have 3 subscript terms. So we need to replace all of them with an x. So we'd get x is equal to, and then it would be x squared plus 0.7x plus 0.02. So the value of the subscript's not relevant. We're going to replace them all with x's, okay, because the idea is when we substitute x in, the next term in the sequence should also be x if we're at a fixed point. Now in this case, we've got a quadratic again, which we can solve. So let's get everything to one side. So we're going to subtract x from both sides. So we get 0 is equal to x squared, and then it'll be subtract 0.3x plus 0.02. Then I'm going to use the quadratic solver on the calculator to get our solutions for x. And those would be 1/5 and 1/10. Now, in contextual scenarios, there might be some other different words used instead of, say, a fixed point. Okay, you might see the phrase steady state, because if you're steady, you're not moving, so therefore it's a fixed point. Or another phrase used in some contextual scenarios might be the word equilibrium, which is once again linked to the idea of staying the same. So just make sure you look out for these phrases in contextual questions, and then if you do see them, they're essentially asking you to find fixed points.